Hello, my name is Cristobal Perez, and today I will present my professional practice at Colbún in the operation and maintenance area. My work focuses on developing a data processing and visualization system for a photovoltaic plant. Um, First, I will explain the context and the objective, and then the system architecture and database. After that, the dashboards, and finally, the results and future improvements. Well, this project was developed for the Volpaico photovoltaic plant located in Cerro Blanco. And the plant has an installed capacity of about 9.9 megawatts with more than 15,000 panels and 28 inverters. The objective was to automate the extraction, processing, and visualization of operational data using Databricks and Power BI. Um, the system has three main stages. First, the data is obtained from the API. Then, in Databricks, Python notebooks perform the ETL process. And finally, the data is visualized in Power BI dashboards. One of the main challenges here was working with raw data. The data was not always clean or consistent, so it required filtering, transformation, and validation. Additionally, the SQL queries were used not only to extract data, but also to generate new tables and do calculates, which increases the complexity. And here we see the data. Sorry, here we see the database structure, and the tables were created for each device, and the variables were defined with specific data types. All tables are connected using identifiers and timestamps. And a key challenge was designing this structure correctly. It was necessary to define which variables to use and how to relate all the data over time. And this was important to ensure the consistency and the scalability. Well, the ETL process starts with authentication and token generation. Then the data is extracted from the API every 15 minutes. And after that, the data is transformed, cleaned, and stored in data frames. Finally, it is loaded into Databricks, then into the Databricks tables, and a scheduled job automates this entire process. Well, using this data, two dashboards were developed, one for daily analysis and one for monthly analysis. First, in the daily dashboard, at the top left chart, we can see power generated by the plant and power consumed by the client versus the radiance over time. From these variables, the system calculates the performance ratio, or PR, which is a key indicator of how efficiently the inverter is working, or the device. The PR compares the actual energy produced with the expected energy, so it allows evaluating the real performance of the plant independently of weather conditions. On the top right, there is a table of inverter alarms to detect the faults. Left below, we have the key indicators such as the best and worst inverters and the performance values, like the median. And there is also a gauge that compares the accumulated daily plant PR, with the contractual PR, and this value is required for the actual month. And this allows the team to quickly verify if the plant is meeting its performance targets. Overall, this dashboard is used for fast and effective operational monitoring. Well, in the monthly dashboard, at the top left chart, we can see the total energy generated by the plant versus the solar resource over all the days of the previous month. And this allows evaluating how the plant performs throughout the month and identifying possible deviations or trends. On the top right, there is a table showing the number of the inverter alarms, which helps identify the units with the highest number of issues. Left below, we have the key indicators such as the best and the worst inverter, as well as performance value for each group. There is also a gauge that compares the, the accumulated monthly plant PR with the contractual PR required for the month. And this allows the team to verify if the plant is meeting its performance targets, as shown as before. Overall, this dashboard is used to analyze trends and evaluate the performance of the plant over the previous month. Well, as a result, an automated ETL process was implemented correctly, along with a scalable database and operational dashboards. And with with respect to the future improvements, included automated alerts, expansion to new plants, integration of more devices, and the time filtering, adding a new time variable. Well, to conclude this professional practice allowed me to develop both technical and analytical skills. It also helped me understand how data can support decision making in real engineering environments. And well, thank you very much for your attention.